Hello, I'm Lynn Bondurant, and welcome once again to our series about America's civilian efforts in air and space during a quarter century. During this program, we cover 1979 and 1980. To put 1979 into historical perspective, that is the year the first man-powered airplane, called the Gossamer Albatross, crosses the English Channel. NASA makes progress too during 1979.
Jupiter, largest of the Sun's 9 planets, was photographed close up by the Voyagers 1 and 2 spacecraft. What their camera eyes recorded as they passed by the giant planet's churning clouds were ribbon-like streaks of red and brown and yellow. The wealth of data and photographs left behind by the Voyagers are providing scientists a valuable source of raw material to be studied. From Jupiter's newly discovered ring to the active volcanoes of Io, one of its 14 surrounding moons, the Voyager discoveries have surprised and delighted NASA scientists. Information that may one day help us better understand our own Earth. And the Voyager's mission did not end at Jupiter. The 2 spacecraft are now speeding toward a rendezvous with Saturn in 1980 and 1981. Acting as pathfinder for the Voyagers, Pioneer 11. The 570-pound spacecraft climaxed 6.5 years and a 2 billion-mile voyage in deep space as it swept by Saturn at 71,200 miles per hour. Scientists watched anxiously as Pioneer made its 2-hour passage of Saturn's rings. 4 times the spacecraft was hit by small pieces of debris, but emerged safely despite the collisions. Pioneer had a closer look at Saturn than all the observations that have been made in the last 400 years. Photographs show what appear to be jet streams swirling around Saturn at 300 miles an hour, a new ring circling the planet's equator, and radiation belts that are more like Earth's in their intensity and energy levels. The Pioneer 11 spacecraft, dwarfed by the objects it was sent to observe, is speeding out of the solar system in an endless journey. This is HEO-3, High Energy Astronomy Observatory, the last of a series of spacecraft designed to study deep regions of the universe where enormous amounts of energy are generated. Launched from Cape Canaveral, HEO-3 is now scanning the galaxies for gamma and cosmic rays in an effort to find clues about radiation from exploding stars and black holes. High-energy astronomy is helping us better understand the universe around us. A new tool for the 80s will be the Space Telescope. Weighing 5 tons and measuring 43 feet long by 14 feet in diameter, the Space Telescope will give astronomers unprecedented views of space, unobstructed by the veil of the Earth's atmosphere. The 94-inch primary mirror, largest astronomical instrument ever to be placed in space, is shown here undergoing initial grinding and polishing operations at the Perkin-Elmer Corporation in Danbury, Connecticut. About 300 pounds of glass will be removed during the lengthy grinding and polishing process. The new telescope observatory is scheduled to be placed in orbit by the Space Shuttle in the 1980s and will circle the Earth at an altitude of 310 miles. This is what NASA's Space Shuttle will look like prior to launch. Shown here during a test rollout is the Shuttle Orbiter Enterprise, sitting on top of its large external fuel tank and between 2 solid rocket boosters. The 2 solid rockets will be parachuted back to an ocean landing where they'll be picked up and made ready for another mission. Preparations for the first shuttle launch continued this year, including a water deluge test. 300,000 gallons of water will be dumped on the spacecraft's mobile platform at the time of launch to counteract damaging noise vibrations of the engines at liftoff. The 16 seconds of waterfall has a sound deadening effect as the engines fire. The 3 main engines that will power the Space Shuttle Columbia into orbit were tested at the National Space Technology Laboratory in Bay St. Louis, Mississippi. The main engines are designed to produce up to 470,000 pounds of thrust, gulping a mixture of hydrogen and oxygen. Problems in testing the shuttle engines continue to cause delays. Small rocket engines called thrusters that make it possible to maneuver the shuttle once in space were also successfully fired at NASA's White Sands test facility in New Mexico. The 154-foot external propellant tank that will hold 1,550,000 pounds of fuel for the shuttle's 3 main engines was rolled out and shipped to the Kennedy Space Center, Florida. The external tank was manufactured at NASA's Michoud Assembly Facility by the Martin Marietta Company. This is Space Shuttle Orbiter 102, christened Columbia. It was named for the seagoing Columbia out of Boston that entered and explored the mouth of the Columbia River in 1792. Captain Robert Gray named the river after his ship. It will be the Space Shuttle Columbia that makes the first trip into orbit around the Earth. The 122-foot-long spaceship, which looks like and lands like an airplane, is being molded into existence by a government industry team of engineers and technicians. 31,000 specially made silica tiles are being mounted on the surface of Columbia, making it possible for the shuttle to withstand repeated heating and cooling, good for 100 or more round trips into space without replacement. Problems encountered in installing the protective tiles have contributed to pushing back the first shuttle launch by several months. Astronauts John Young and Bob Crippen will pilot Columbia on its maiden voyage into space. They are ready, and despite some troublesome delays along the way, all the parts and pieces of the new space transportation system are coming together and approaching launch readiness. There were several major events that occurred during the year, including adding 35 men and women to the astronaut roster. The 35 completed a 12-month training program and will be the pilots and mission specialists as the Space Shuttle becomes operational. Much attention was given during the year to the reentry of Skylab. Launched in May 1973, Skylab was manned by 3 different 3-man crews for periods of 28, 59, and 84 days, during which many scientific experiments were conducted. Since early 1974, the uninhabited Skylab had been slowly descending. Early in the year, it became apparent that the 77-ton space station would re-enter the atmosphere in the summer. Skillful manipulation of Skylab's small amount of maneuvering capability, combined with good fortune, resulted in debris reaching the surface in the Indian Ocean and in sparsely populated areas of Australia, causing no damage or injuries. In space applications, remote sensing from satellites like Landsat are being considered more as operational tools by the Departments of Agriculture and Interior. Remote sensing makes it possible to inventory and predict world food crops, for instance. Consider these pictures taken by Landsat as it tracked the Mexican Gulf oil spill. Large area views like this have been very useful to the U.S. Geological Survey and the Mexican government. Using computers and the GOES-1 weather satellite, NASA is working with the University of Florida and the National Oceanic and Atmospheric Administration to develop a system to warn citrus growers when freezing temperatures are about to occur. This type information alerts growers when they should fire up their oil heaters to save their crops from freezing. NASA's Marshall Space Flight Center has taken technology needed to design highly efficient pumps for rocket engines to develop new, lightweight firefighting water cannons for the Coast Guard. These portable units can easily be transported where they're needed and can draw water from anywhere, including the sea, with a pumping rate of 1,000 gallons per minute. To study the ozone layer and effects of aerosols on that region, a stratospheric aerosol and gas experiment satellite called SAGE was launched from NASA's Wallops Flight Center off Virginia's eastern shore. To compare the information received from satellites like SAGE, scientists and engineers from 5 countries also launched 20 small rocket-borne experiments from Wallops Island. Changes in aerosol concentration may cause changes in climate, with important implications for agriculture. Energy-related research is continuing to be part of NASA's overall effort. A wind energy program supporting the Department of Energy is just one example. The third in a series of 200,000-watt wind generators began operating on Block Island, Rhode Island. It can electrify up to 250 homes there during the winter. That's half the permanent residents on the island. A much larger wind turbine, able to produce 2 million watts of electricity, began operating atop a mountain in Boone, North Carolina. Residents in the Papago Indian village of Stuchalik, Arizona, are enjoying electrical power provided by solar energy. The 3,500-watt photovoltaic village power project was funded by the Department of Energy, the Papago Tribe, Public Health Service, and the Four Corners Regional Commission. It is managed by NASA's Lewis Research Center in Cleveland. NASA's Jet Propulsion Laboratory in Pasadena took delivery of a new electric test vehicle. Developed by General Electric and Chrysler for the Department of Energy, the sleek electric car is scheduled to undergo extensive testing. ETV-1 can range from between 75 and 120 miles before recharging and has a top speed of 65 miles per hour at an estimated operating cost of 18 cents a mile. The car uses 18 lead-acid batteries, good for 30,000 to 50,000 miles, and can be recharged by plugging into an ordinary household outlet for 8 hours. Engineers at NASA's Langley Research Center are studying aircraft structural design, including improved seat and restraint systems that could increase the probability of passenger survival and also reduce injuries when a general aviation airplane crashes. They do this by intentionally crashing planes into the ground at varying angles and speeds. This rocket-assisted crash allowed the researchers to impact the plane at 90 miles per hour. Onboard cameras and instruments give precise information that can be used to improve the crashworthiness of future aircraft.
1979 is a year of advancement for NASA. To put the following year, 1980, into perspective, that's the year a new disease called toxic shock syndrome attacks young women. And in 1980, the Supreme Court rules that forms of life made by gene splicing may be patented. 1980 is the year scientists announced life is discovered to have been on Earth for 3.5 billion years. NASA continues to progress in 1980 as well.
These people, here in Mission Control, were responsible for guiding NASA's 1,800-pound unmanned Voyager 1 spacecraft some billion miles through space. On November 12th, after a 3-year journey, Voyager 1 made its closest encounter with the planet Saturn. Voyager has returned more than 18,000 photographs. Photographs that are giving scientists excellent close-up views and new information about the huge planet and its many moons. With the help of computer animation, you can take a ride on Voyager to Saturn and its major moons. Voyager's 11 scientific instruments probed deep into the atmosphere of Saturn and gave us an unprecedented view of those incredible rings. We now know there are 6 major ring systems, made up of possibly as many as 1,000 rings. The rings are sun-reflecting icy objects, ranging from boulder-sized to small particles that whirl around the planet at very high speeds. And those moons or satellites, like outriders, they encircle Saturn, generating as much scientific interest as the great ringed planet itself. Mimas, Tethys, Dione, Rhea, Titan, and a host of smaller ones. Next August, Voyager 2 will approach Saturn, pass by the ringed spectacle of gas and ice from a different angle, and then fly on to Uranus, arriving there in 1986. It may also travel to Neptune before leaving our solar system. From Earth, it appears as a warm, friendly ball, an integral part of everything living. But up close, it's a churning solar furnace that spouts solar flares in an atmosphere that's constantly changing and explosive. Little wonder that our star, the Sun, has been the focal point of scientific investigation for centuries. To relay sophisticated pictures and data about the Sun and its energy cycles, NASA launched the Solar Max in 1980. short for Solar Maximum Mission. Being returned are the first true close-up views of the mysterious spots and solar flares that energize the sun's surface. All this part of an effort to learn how we can channel the sun into an even more effective energy source. Closer to Earth, sounding rockets probe below where satellites orbit. And balloons carry heavy instruments that need a longer flight time than sounding rockets provide. Both play an important role in the scientific study of the Earth's atmosphere, everything from measuring the amount of ozone to gamma-ray radiation. Work on NASA's reusable space transportation system continued at many levels in preparation for the upcoming first launch. Practice recovery runs were made to retrieve the 2 solid rocket boosters that will be used to help launch the Space Shuttle. Just before going into orbit, the big rocket boosters parachute back to an ocean landing, where they are picked up and made ready for another launch. The shuttle orbiter's main engines have successfully passed firing tests, singly and clustered in a group of 3. They too are ready for launch. Installation of thermal tiles that protect the spacecraft from heat buildup during re-entry are now in place and ready for the flight. This is how the entire space transportation system will look. The airplane-like orbiter is attached to the main fuel tank with the 2 solid rocket boosters on each side. A new type spacesuit has been developed to provide an Earth-like environment as well as thermal protection from the sun. The advanced spacesuits have 3 basic parts: a body-cooling undergarment, a puncture-resistant pressure suit, and a life support backpack which contains 7 hours of oxygen and controls the suit temperature. This is astronaut Bob Crippen. It is he and John Young who will pilot the first shuttle flight. Since the shuttle orbiter glides back to Earth to an unpowered landing, it's important for the astronauts to have practiced these types of landings in advance. They do just that with a specially modified jet plane designed to handle and feel the way the shuttle does during final approach and landing. Crews are also training on this vertical motion simulator. It reproduces the motion an astronaut at the controls of the shuttle orbiter would feel during approach, flare, and landing without leaving the ground. Preparing for a busy shuttle flight in the years ahead, NASA selected an additional 19 men and women to begin training as astronauts, and that training is well underway. Many of the astronauts recruited earlier are learning to fly the Manned Maneuvering Unit, a compressed gas backpack that will enable the wearer to move around outside the shuttle in space on future flights. At another facility, engineers are working to develop procedures and hardware that will be needed for astronauts to build large structures in space. And they do it underwater, more than 1 million gallons of water, to simulate weightlessness. In space applications, the GOES-4 weather satellite was checked out and launched from the Kennedy Space Center, Florida. Weather forecasters and other scientists are using the satellite to study severe storms, flash floods, and tornadoes. This GOES East satellite picture taken last summer shows both Hurricane Allen over the Gulf of Mexico and Hurricane Isis in the Pacific Ocean. Ever since the spectacular eruption of Mount St. Helens, NASA has been working closely with other scientists to assess the impact. One of NASA's high-altitude U-2 aircraft sampled the air within 100 miles of the volcano. Recently, a plane from the Langley Research Center in Virginia flew a group of scientists and their instruments near the mountain. Among other things, they attempted to find out how much and what kind of gases come out of volcanoes. Worldwide, there's very little volcano data available. Energy from sunlight to power spacecraft is very important. Now, technology is being studied as a way to harvest thermal energy from the sun here on Earth. This is a research version of a solar farm. The dish-shaped concentrators are covered with mirrors, which reflect and focus the sun's rays to a point where the intense heat is converted to electricity. Rows of these collectors may one day help provide electric power for a small city or factory. It's part of a joint national effort by government and industry, sponsored by the U.S. Department of Energy. NASA's Lewis Research Center also worked with the Energy Department to develop this 200,000-watt wind turbine generator. Hawaii's strong trade winds blow year-round, making it an ideal location for electricity-producing wind machines. This one, which began operation last July, is located 45 miles north of Honolulu. 1980 was a busy year for NASA's various aeronautics programs. Consider this rotor systems research aircraft. These unique craft can be flown not only as helicopters, but also with wings and jet engines. The studies will investigate promising new helicopter technologies to improve performance, reliability, and safety. This strange-looking plane is the QSRA, which means Quiet, Short-Haul Research Aircraft. It can land at speeds slower than many light airplanes, about 75 miles per hour, and can brake to a stop in 600 feet. In a cooperative test with the Navy last July, the QSRA made 37 touch-and-go landings and 16 full stop landings without the help of arresting gear or catapults aboard the carrier USS Kitty Hawk. This was the first time a four-engine jet transport ever operated from an aircraft carrier at sea. In the future, the technology from the quiet-flying QSRA may also help improve transportation services to many airports with very short runways. The XV-15 tiltrotor is another research aircraft that shows promise for both military and civil applications, including intercity transportation and for moving people and equipment to offshore oil rigs. The craft's helicopter-like rotors allow the XV-15 to take off and land vertically. Once airborne, the rotors tilt forward for cruise flight at over 300 miles per hour. The tiltrotor concept achieves twice the range of a helicopter using the same fuel. Bridging the gap between wind tunnel models and full-scale aircraft is HIMAT, Highly Maneuverable Aircraft Technology. After being carried aloft by a B-52, HIMAT drops away. However, the pilot never leaves the ground. From here, he can fly the remotely piloted vehicle through any number of complex maneuvers and high-speed turns. This has proved to be an excellent technique for doing high-risk flight testing less expensively and with no danger to the pilot. This small jet-powered research plane takes off and lands like most aircraft. But in flight, it's unlike anything flying. The pilot of the scissor wing concept plane can pivot the wing up to 60 degrees, decreasing the air drag and making it possible to fly faster and farther without increasing fuel consumption. The AD-1 scissor wing has made several successful flights. At Manassas Airport in Northern Virginia, pilots have always landed with no help from air traffic controllers. But now, something new is in the air. It's an experimental automated pilot advisory system, APAS. NASA's Wallops Flight Center developed APAS and has successfully demonstrated it at the Manassas Airport in cooperation with the Federal Aviation Administration. As pilots approach the airport, they can turn their radios to a designated VHF channel, and a computerized voice tells them the location of all planes in the landing pattern. The FAA will now determine the merits of this and a similar automated system for possible use at many small airports around the country, adding a greater margin of safety for general aviation pilots.
And those are some of NASA's 1980 highlights. Please join us for our next episode of 25 Years of Progress, when we look at NASA during 1981 and 1982. I'm Lynn Bondurant.
Roger, Columbia, on a roll. Columbia, Houston, your go at 40.
Roger, go at